Hello everyone, in this tutorial, I will create all the function that is necessary for the animation blueprint. And we're not yet working on the state machine because it might confuse you. So we only create all these variables and use it later in the next tutorial. First, go to Echo Locomotion and we choose animation blueprint and choose SK mannequin and create. Name it Echo Anim BP and open C8 Echo. Click on mesh and choose anim class is Echo Anim BP. Can open Echo Anim BP. Go to event graph. Add new function. Name it set reference. Then get owning actor has to C8 Echo. Then right click on C8 Echo, promote to variable and name it Echo character. Then get character movement and promote it to variable. The name is character movement and get mesh. Promote to variable. Rename it to Echo mesh. And for our echo character, we set the category to reference. And this echo mesh, change it to reference. And character movement is our reference. In the event graph, event blueprint initialize animation. This event called before the update animation. And the first thing we will do is get set reference. Then add new function. Name it set essential movement data. And create the sequence. On the first sequence, we get character movement. then get velocity, and promote variable to velocity. And this velocity category is essential data. Click on the essential data. And the length of this velocity, motor variable, the length of it is speed. Then get character movement and get max speed. Then promote it to variable. The name is max speed. Add pin. Get character movement. Get last input vector. And clamp vector size. Min is 0 and max is 1. Then promote it to variable. The name is input vector. Make it to then. Add pin. Get character movement. And it's falling. Mode it to variable. Name is falling. And we can double click on this line. And move this to make it cleaner. Right click, align and align left. And all this variable is essential data. We get this data from the character movement. Go to event graph and promote this data time x to variable. And this is the essential data too. Then get echo character, right click and convert to validate get. If it's valid, we call set essential movement data function. And we get this data every tick. Then add function. Name is movement within threshold. And this one we call return node, and it is pure function. At input, the input name is min current speed. Set it to float. At variable min max speed. And another variable is min input acceleration. Then check if it less or equal to the speed. The current speed less or equal to the speed. And the min max speed less or equal to the max speed of the character. And the min input acceleration less or equal to input vector length. And all these three conditions with n boolean, and we return it. With this condition, we can figure out what is the locomotion state of the character. Is it idle, walk, or jog? Add new function. Name is determine locomotion state. And get is falling, not boolean. Create a branch. If it's true, we continue to find the locomotion state because it is not falling. And get velocity. Normalize. Get character movement. And get current acceleration. And call normalize. Dot product with these two vectors. And if it less than minus 0.5, we create a branch connect to true. And then we create a new folder in the echo locomotion. Name it data. And open this data folder. Right click in the blueprint. Click on enumeration. Name it enum locomotion state. Open this and we add enumerator. Display name, the first one is idle and add name is walk and another one is jog. Because we have three states that our character do is idle, walk and jog. Can close this. And in the determine locomotion state, when this dot product is less than minus 0.5, we set the locomotion state, but we have to add variable first. Variable name is locomotion state and variable type is enum locomotion state. This one enum locomotion state that we just created, and set this state to idle when it's true. Then call each movement within threshold. The current speed is 1. Max speed is 300. And the acceleration input is 0.5. And create a branch. When it falls, we check this threshold. If it's true, we set this locomotion state to jog. It's happened when the player press shift. And if it falls, create a branch and create each movement between threshold. Mean current speed is 1. Max is 0. And the mean input acceleration is 0.01. And if it's true, we set the locomotion state to walk. The speed is between 0 to 300 when it is walking. And if every threshold is false, we set locomotion state to idle. You can print string to see this effect. Idle jog. Set the duration to 0. This one set to 0. And copy this. Walk. And idle. Go to event graph. On the update, after we set a session movement, we call determine locomotion state. And let play test. Now the player is idling. And when we press W, player is walk, and press shift, player is jogging. But we not yet have the animation. Now let's delete this debug. Print string. Add function. Add macros. And the macros name is track locomotion state. And the input is locomotion state. Variable type is locomotion state enum. And then add another input and set it to execute. Move it up, holding this, and move. The name is execution. The name is can be executed. When the name is executed, we don't have this name on this variable. And equal to another enum and get locomotion state and create a branch. The output add variable. The name is on entry variable. The name is on exit and while true and while false. We want to check that if the locomotion is the same as the last locomotion state. Then create, if it's true, create a sequence. And connect it to while true. When it's true, it always get this exit while true. And if it false, create a sequence and go to while false. Then call do one and create a sequence. And this one we call do one. Create a sequence. And if it's true, we set redo, reset this do one. And if it false, we reset this do one. And the result, when it's true, it call on entry, and when it's false, on exit. This on entry happen only one time because we have this do one. And when it exit, it can entry again because we will call the reset after it is false. And this exit, we only call one the same as the on entry. Now go to event graph. And after we determine the locomotion state, we create a sequence and add pin. Call track locomotion state idle. And the second is track walk. And the third is track jog. We want to know that if the locomotion state is walk on int3, the first time it walk and it switch to jog, it will exit, call this exit. Then add new function, name it update locomotion value, get speed, save device. We use save device because we don't want to get the error or crash when it's divided by 0. When it divided by 0, it is 0, not infinity. And get curve value. And the curve name, we can go to the animation and open this idle to jog and this move data speed. Pass this name, move data speed, and claim float. The min is 50 and max is 1000. Divide it and promote it to variable. Rename it to play rate. And this is the play rate of the animation we get from the move data speed. And go to event graph. On while true, we call this update locomotion value play rate, and this while true jogging, we call this update locomotion value too. Because this one, when the player move to the wall and then the player cannot move forward, the animation will slow down the play rate of this animation. We close this function first and add function. The name is update on walk int3. Get speed, and if it's less than 50, create a branch. If it's true, create a sequence. Get echo character. Get actor rotation. And promote it to variable. Name it start rotation. Then get input vector, create rotation from x vector and promote it to variable, and name is primary target rotation. Then duplicate this variable. Name is secondary target rotation. Set it to the secondary target rotation. This rotation, we want to know the start rotation of the character before we start walking. And this is the target rotation. To know the rotation angle, and we will play the correct rotation animation. If it starts with left, the character have to turn left. If it starts with right, the character have to turn right. Then add pin. Get primary target rotation. And get start rotation. Call delta rotator. Split it. And this z value, your remote to variable. And name is walk start angle. And then add pin. Add variable. Name is play walk start. Variable type is boolean. And this is set the play walk start to true, because we want to play the walk start animation, transition from idle to walk. And double click on the line. And this rotation category, we change it to rotation. This rotator, we choose rotation category. And this variable locomotion state, name new category is locomotion. Display rate is locomotion. Walk start angle is locomotion. Play walk start is locomotion. Then add new function. Name is update on jog entry. And get speed less than 200. Create a branch. If it's true, create a sequence. And then get echo character. Get actor rotation. And set it to start rotation. Get input vector. Get rotation from X vector. and set it to primary target rotation. And then set this primary target to the secondary target. And get this to this primary target rotation and start rotation. Call delta rotator, split it, and the yaw, we promote it to variable. Name is chop start angle, and add pin, connect it to chop start angle. This chop start angle is the same as walk start angle. To find which animation that we should play, the turn animation, can turn back, start walk forward or left or right. Then duplicate this play walk start by pressing Ctrl D and name it to play jog start and set it to true. Now set this jog start angle to locomotion category. And then add new function. Name is reset target rotation. And get a character, get actor rotation, and find the primary target rotation, set it to this actor rotation, and set it to secondary target rotation. When the speed is less than 50, it means the character is slowing down and stop walking. It start to idle. So we reset target rotations, and on update jog, when it's false, we reset target rotations. Go to event graph. On the track locomotion state of the walk on entry, we call update on walk entry, and this one update on walk on jog entry. This update on jog entry, we get the angle, we get this angle start of the jog. Now close this variable category and add new variable. Name it walk state data, and variable type is catch anim state data. Duplicate it. Name is jog state data. and duplicate it again. Name is locomotion state data, and the category is state data, and set the box to the state data category and the jog state data too. Add new function. Name is update character rotation. And then we get the locomotion state data and call state machine is state relevant, and in anim instance or save and boolean get echo character and call has any root motion, connect it to n. We have to call not boolean before we call n. Then create a branch. If it falls, we reset target rotations. And if it's true, get locomotion state. And then call switch on enum locomotion state. This function, we want to rotate the character when it starts walking or start jogging, and when the character is walking and jogging. Add new function. Name is get target rotation and set it to pure function. And add variable. The name is do input vector rotation. The variable type is boolean and category is rotation. Then get this do input vector rotation, create a branch and call return. We have different return when it's true and when it's false. Get input vector, then call rotation from X vector, connect it to the return node, and we then disconnect it and split struct pin, and split this struct pin too, connect it to yaw. Get velocity, call rotation from X vector conversion and split it. Split this return value, connect it to yaw. And on update character rotation, when the character walk locomotion get target rotation and set it to primary target rotation, it to walk, and then call or interp 2, connect it to the return value, and this is the target, connect to the current, and then get the data time x to data time. The interp speed is 1000. Can compile it first. And then set secondary target rotation. Call or interp 2 it to the current and get primary target rotation, data time x to data time, and the interp speed is 10. Then get echo character and set actor rotation. Make rotator next to new rotation, and get secondary target rotation. Split it, connect it to roll, pitch to pitch, get curve value, and the curve name. We have to find idle to walk forward, and this move data, walk rotation data, and pass it in the curve name, and save device. State machine global weight, and we get walk state data, and in any instance is saved, and connect it to the device and add it with the yaw. And this will set the rotation of the echo character when it turns. And you can copy this, pass it, and connect it to jog. When the character jogging, we get the curve from jogging. Move data, jog rotation data, and get jog state data instead of walk state data. And now it controls the rotation of the character when turned while jogging. Go to event graph and create a new event. event blueprint post-evaluate animation. This executes after the animation is evaluated. So it calls every tick. And then get echo character and convert it to validate get. Then if it's valid, we update character rotation and add new function. Name is reset transition. And then set play walk start to false and set play jog start to false. The transition happens when the character change from idle to walk or walk to jog. At that time, the character can have the turn animation. And after that, we call reset transition. You can close all these functions. And for walk state data, when it state machine name is locomotion and state name is walk. And jog state data, the state machine name is locomotion and state name is jog. When we create the state machine, we have to use this name the same as this catch and name data. And locomotion state data, the name is main states. State name is on ground. Now we finish all the function and variable in the anim blueprint. Let's open Windwalker Echo project and open the animation idle to jog forward. And we can see this notify that have foot left and foot right. And this notify told the engine about when is the foot step on left foot and when is the character step on right foot. And it told about the number of cycles in that animation. So when we have the transition, it get the smooth transition from idle to walk or walk to jog animation. You can read more about scene group in the documentary of Unreal Engine. And if you don't assign it, you can have this weird looking transition with the animation. So go to this animation and back to our project. Open the same animation. And then point your mouse on the notify and you can see the frame that the foot L is called at frame 10. And on our notify, right click, add scene marker, and existing scene marker left, and this left notify, right click and set the notify frame is 10. Continue with this, put right frame 23, right click, add scene marker and all, and 23. You can use this and set the scene marker by the animation, or you can make it accurate, copy from that echo project. And this one 32, put left, set it to 32. Put right 41. Put left 51. Put right 60. Put left 71. And put right 82. And you can see this animation. We finish at the marker of the foot left and right. And you can continue this process for every animation that have that notify. I will cut to the result. And this is the finished result of our animation scene group. And you can see the foot location, notify, and all this star sign is the animation that I modify it, add the notify on it. And when we save all, we lose all this star. In the next tutorial, we will create the machine state for our character. Thank you very much for watching, and if you like this video, please hit like and subscribe to my YouTube channel, and see you in the next video.